Hi guys, welcome to today's session. Today we are going to see the topic of Python. In Python, we are going to see conditional statements and sequence types. Before entering into these two topics, we can see the basics like Python's history, data types. That's going to be our second slide. Yes, we are going to see this is our agenda for today. History of Python, installing and running Python, the basics, conditional statements, sequence types, mutability. We can go from scratch onwards. Yes, the Python's history was Python is invented in Netherlands on early 90s by Guido van Rossum. This name was named after Monty Python. It is an open source software we can install in every systems which it supports this Python language. It's a scripting language, but it can do much more things more than that. It is one of the scalable languages. We can do object-oriented programming, many functional, many functional from the beginning. Google is using this language from the beginning of its invented date. People are much more getting familiar with this language and it's getting popular day by day. This is one of the famous quotes said by the founder. Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. This is the latest version of Python 3.11.4. The versions are getting updated day by day. You can simply click this download button and then you can go into the downloads and select that folder and give run as administrator. Then you can use the Python easily. That's it, the installation process. Now we can go for running it. Typically Python implementation offer both interpreter and compiler. It is one of the biggest advantage in Python programming language. It has an interactive interface. Here is a small program which gives a square of the number. Now the 1 square is 1, then 2 square is 4. This is the output of this program. Next, this is the installing process. Python is pre-installed in most of the Unix systems including Linux and Mac OS. Yes, Python is pre-installed in these OSs. The pre-installed version may or may not have a recent one. Yes, of course. Uh, this this pre-installed systems will have some of the older versions, but in our Windows it is not pre-installed. Why? Because they doesn't provide such kind of offers. But we can work as a IDE. Now we can see what is meant by IDE. IDE, an integrated development environment, is a software application that helps programmers develop software code efficiently. Yes, we can work our code in IDE. Like you may have seen that previous languages, Java IDE, Python IDE. Likewise, these are some IDE softwares, PyCharm, Anaconda, and etc. etc. We can code in these IDEs and we can develop. Yes, this is the IDE interface. See, there's the older version of 2.3.4, but now the latest version is 3.11.4. Ideally, integrated development environment for Python. It is used in Windows often. Multi-window text editor with syntax, highlining, auto completion, smart indent, and others. Yes, you may have seen in Visual Codes. It may be familiar thing. In Visual Codes, if we type just example, we can take Java. If we type print out, it will print that system.out.println automatically. We can use that tool often. These IDEs are very helpful for that. Python shell with syntax highlighting. We can see this here. This for loop, the for is highlighted. That for loop things are highlighted. Then this print is highlighted. So this IDE provides such kind of services. Next, as it also has some integrated debuggers. It will automatically correct some small mistakes if we do. It will clear the breakpoints and call stack visibility. Likewise, These are all will be very helpful for developers in developing in IDLE. Now we can jump into basics. Basics in the sense we are going to see about data types, then operators. First, let's see a sample program. You might have seen all this program in every other languages, but see how simple it is in Python. If you take this program in Java, we should have a class name, then we should call the main method, then all the things, then system.out.println, then hello world. But it's really easy in Python. Just print hello world. That's all. This is the output. Likewise, the Python is very simple for developers. It will save our time also. It's a small additional programs. See, a variable, we give the value as 10. First variable means we should store our data in some place. So we are giving a as a variable, then we variable as 10. To understand easily, let's take a real-time example. If we have to store apple, we will have a tray. The tray is the variable, that apple is the value. Likewise, we stores value in variable, then afterwards we are storing these two values in this c variable, then we are printing c, a plus b. What's a value is 10, then b value is also 10, then the output will be a plus 10. 10 plus 10 is equal to 20. These are all some data types. Numeric data types will have integer, float means decimal values, then complex. String will be represented str, then sequence we are going to see today about this only. In sequence, there are list, tuples, and arrays. And then binary will be denoted as bytes. Then boolean will be denoted as bool. Bool will return true or false type of data. Then another sample program using data type. Now a. In this a, we are storing hello. String will all be denoted in double quotes. See here, in a variable, the hello is a string. It is denoted in double quotes, so it's a string. Then in b, the world, it is also a string. By adding these two strings, we will get hello world. Likewise, it is a string data type. Now we will see in the integer data type. Like a previous one, we can see a adding program. A value is 1 and b value is 2. By adding these two integer, we get 3 as an output. Now we'll move on to the operators. Operators. Operators are used to do some operations like addition, subtraction. These are all some basic operations. We can do many other operations than that, like assignment operations, then comparison operations. See here, this addition symbol is operator, then these other two values are operands. First operator, we can go one by one. Arithmetic operators. Arithmetic operators you will all have studied in all your schoolings, like addition, subtraction, then multiplication, division, module operator, then exponential operator, then floor division. The first addition operator does additions, then subtraction. These are all some kind of familiar operations. Modulus operator gives the remainder value, then this operator gives the square of the number, then floor division. Let's see an example program. Here there are two variables, a is 7 and b is 2. We'll do operations with only these two numbers. Repeat some different operations. Now see here the print. This is a data type. We'll the print statement, which are all things we give in quotes, it will print as it is. First is addition operation, subtraction operation, then multiplication operation, division, floor division, modulo, then power operation. See, now we get the output as 7 plus 2 is 9, then 7 minus 2 is 5, then 7 times 2 is 14, then by dividing 7 with 2 is 3.5, then the modulo operator, the remainder will be 1, then floor division, the answer is 3, then by power 7 square is 49. Next operator, Next operator is assignment operator. This assignment operator is these are all things. Now we can give simply as equal, plus equal, minus equal, multiplied equal. Like these operations will be performed here. The meaning is x is equal to 5 is same as x is equal to 5. Then x plus equal to 3 means x is equal to x plus 3. This is the assignment operator. Likewise, x minus equal to 3 means x is equal to x minus 3. Likewise, we will see some sample program here. Same addition program but using assignment operator. A is equal to 10, B is equal to 5, then A plus equal while printing A. This operation will take as A is equal to A plus B already. Now the A value is 10, so A is equal to 10 plus B value is 5. So 10 plus 5 is equal to 15. This is the use of assignment operator. Next operator is comparison operator. Comparison operator. Comparison operator means we'll compare both the things like it's equal or not equal or greater than or less than or greater than or equal to or less than or equal to. We'll compare two things and we'll have a result. We'll see a program. Here also the same program. By using only two variables, we will perform all the tasks. First, in this the answer will be written as true or false only. Why? Because we are only comparing those things, not we are expecting for any other answers. We are just comparing those two variables. Here a is equal to b, that is the first operation. A value is 5, then b value is 2. Obviously not, is a is not equal to b, then a not equal to b. A not equal to b, yes, a is not equal to b, so the answer will be true. Then a is greater than b, yes, of course the answer will be true. And a is less than b, no, it's false. Likewise, we can perform all these operations. Then logical operators. Logical operators will also return true or false only. Logical operators will be performed like returning true if both statements are true. If both statements are true, then the answer will be true. Now, if we assign the value for x as 20, this both statements will become true and the main answer will be also true. Now, OR operator. OR operator will be returns true if one of the statements is true. If one of those two statements become true, then it will also return true. Then the not operator. Not operator will be giving the answer as opposite answer what we get. See, the reverse the result returns false if the result is true. It will return as false if our result is true. This is not a program. Print true and true. What we have seen in AND operator. If both the statements are true, it will return true. Print true and true means answer will be true. Then in AND operator, both the statements should be true. Then only it will give us true. So there is one true and one false, so it will be false. In OR operator, if one of the statements become true, we'll get the answer as true. Here we got the answer as true. Next, not operator. Not operator, it will reverse our and it will reverse our result. If the answer is false, it will return as true. If it is true, it will return as false. This is performed here. Next operator is identity operator. Identity operator. Identity operators are is and is not. Is the description is returns true if both variables are the same object. Then another operator is not. Returns true if both variables are not the same object. X is y and x is not y. First, two variables. Here we are comparing these two variables. X1 is equal to 5, then y1 is equal to 5. Now we can directly go here. Print x1 is not y1. Here these two variable values are true, same only. X1 is also 5, then y1 is also 5. Then the answer should be true if x1 is y1, but here the operator used is x1 is not y1, then obviously it is false. Then here x2 is equal to y2, x2 is also hello, x2 is equal to hello, y2 is equal to hello. These two are same, x2 is also hello, then y2 is also hello. Then the answer for here x2 is y2 is true. Next operator is membership operator. There are two operators, in and not in. Returns true if a sequence with the specified value is present in the object. In not in operator, returns true if the sequence with the specified value is not present in this object. We can see a program. Here, in X there is hello world, and in Y there are first. Let's see a sample program. In X there is hello world. First we should print X in X, H in X. Now we will check that in X there is any word H or anything. As in hello world there is H, so the output will be true. In this operator will also it will return as true and false only. Next operator is bitwise operator. Bitwise operators, there are many bitwise operators like and or, XOR, not, 0, left shift, sign right shift. Likewise, AND operator does sets each bit to 1 if both bits are 1. It is same as the AND operator we see before. Likewise, OR operator, it sets each byte to 1 if one of the two bytes is 1. Then in XOR operator, sets each byte to 1 if only one of the byte is 1. In NOT operator, it inverts, it gives the opposite value of the result. Then the 0 fill left shift, it returns as shift left by pushing 0 in from the right and let the leftmost bit fall off. The opposite will be the right shift operators work. These are all operators used in Python. Next, let's go to the conditional statements. Conditional statements are used to check the possibilities, like if it happened what we can do, or else it should do some another work. Likewise, it is used to check these conditions. Let's see one by one. First, sample. First, if statement. The if statement is the most simple decision making statement. It is used to decide whether a certain statement or block of statement will be executed or not. The syntax of if condition is this only. If condition, statement to execute if statement is true. This statement will be executed when only this condition gets true only, or else it will get out of this condition. Next, one sample program. Now, the I value is given as 10. See, in if condition will give us if I value is greater than 15, we should print 10 is less than 15, or else we should print as I am not in if. It is getting out of the if condition. Now the value is 10. 10 is greater than 15 or not? No, it's not greater than 15. So this condition will get false and it will go directly I am not in if. This is the if condition. Next to else if. The block of code following the else statement is executed as the condition present in the if statement is false after calling a statement which is not in the block without white spaces. We all know that Python is case sensitive and it will also take all these white spaces. We'll also have some indentation errors. Now let's see an example for else if condition. Here the I value is equal to 20. We can go into the conditions. If I value is less than 15, it will print as I is smaller than 15. Then it will print I am in if block. Else it will print as I is greater than 15. Then I am in else block. Here the I value is 20, I value is not less than 15, so this true, if condition will get false, then it will go check this condition. Here the I value is greater than 15, it will print as 20 is really greater than 15, so it will print this else condition. I is greater than 15, I am in else block. Next, nested if. Nested if is next nested if. A nested if is an if condition that is the target of another if statement. Nested if statement means an if statement inside another if statement. It will be Python allows us to nest if statements within if statements. We can place an if statement inside another is yes, as I said already. We can place if condition inside another if condition. Only when this condition gets false, it will check the another condition. Then afterwards, if this is also gets false, it goes to else condition. Python indentation. Indentation is nothing but spacing. Indentation refers to the spaces at beginning of code line. There is some certain conditions in Python to give spaces before or after some conditions. Where in other programming languages, the indentation code is for readability only. This Python, it is really very important. Python uses indentation to indicate a block of code. In other languages, we give spaces only for our convenient to understand the code or read again and again. But in Python, it is a default one. We should use only like that. Likewise, it is very important to follow the intention. Here, a sample program for the intention. Now here, in an if condition, there is some space for this next print statement. If we give like this, we will get the output as 5 is greater than 2. Then if we didn't leave space, we will get the output as intention error expected an intention block. If we give space here, we will get the output as same 5 is greater than 2. Next, here we in previous programs we give the input value as 20, but if we should check one or two times more than that, we cannot execute the program again and again. So we can get input from user from this. See, Python allows for user input. We can able to ask not in Python only. We can also ask in many other programming languages, but it is really simple in Python. We can give simply as we can declare a variable as username, and if we give input, it will print first enter the username in the beginning of execution. We should print the statement as username is the variable value. We can get this variable value from the user in the output screen. Now first after executing, we will only get this enter the username. Afterwards we can enter as Raj. Then the output will be username is Raj. Naming rules. There are certain rules to give for a variable. We all know that Python is case sensitive. The names are case sensitive and cannot start without a number. The names cannot be started with first with number. They can contain letters, numbers, and underscore. They can contain all these kind of things, but it's not start with number. Likewise, it can start with Bob. Only have letters and underscore at the first, not with numbers. Likewise, we can do all this. These are all some of the terms we use in Python. Like elif, we can use for else if conditions. Then else. Likewise, these are also should not used in Python while we are programming. Like giving names to any other things. The Python community has these recommended naming conversion. Next is naming conversions. The Python community has these recommended naming conventions given below, like joined lower for functions, methods, and attributes. then join lower or all caps for constants, then steadily caps for classes, then camel case only to conform to pre-existing conventions, then attributes for interface, internal or private like this. These are all some name conventions. And accessing non-existent names. Accessing a name before it's been properly created by, for example, by placing it on the left side of an assignment, raise an error. Here, if we just simply type y, we will get like this error only, like line 1 in top level. Name error, name y is not defined. We didn't define anything for this y. Here we defined y is equal to 3. Then after we are printing y value will printed as 3. This is accessing non-existent name. It will also raise an error for these kind of cases. Now let's get into topic. Sequence types. Sequence types means like tuples, list, and strings. We can see everything. Sequence types. In sequence type, this tuple. First of all, tuple. Tuple will be denoted in this normal brackets. We can insert any kind of values. A tuple is immutable ordered sequence of items. Items can be mixed types. We can use here also. We have used that. We have used string, integer, and array also. We can use mixed types including collection of types. In strings, normally strings will be denoted in double quotes. String is also immutable. Conceptually, very much like a tuple. It is similar. It is really similar like a tuple only. These two are immutable, but this list is mutable. List can also carry many mixed type of datas, mutable order sequence of items of mixed types. Tags. All three sequence types, tuple, string, and list, share much of same syntax and functionalities. These three sequence types will have the same type of syntax with very little difference. Some of the key differences are tuples and strings are immutable. List is mutable. The operations shown in this session can be applied to all sequence types. The most examples will be just shown the operation performed on one. First, sequence types 1. Define tuple using parentheses and commas. We can use tuples by separating with commas, using square brackets. We can define lists using square bracket and commas. Then we can define strings using these quotes, any kind of quotes. Strings in tuples we have mixed type of datas like 23 ABC 4.56 like this. Then in list also we have mixed type of datas. Here is a string, then integer, then float. But in string there's only characters like hello world. This is multi-line string that uses quotes. We can only refer using this double quotes or single quote or triple quotes. Next, sequence type 2. Accessing individual member of tuple, list, or string using square bracket, using array notations. The very important thing is this all places as an index value. This 23's index value is 0, then this string's index value is 1. Likewise, the base value is 0, and afterwards only it will get 0, 1, 2, 3, 4 likewise. Next one, simple program into the value in the index value of 1, index place of 1. that is, what is this, its value is 0, then it's 1, so the answer will be ABC. And in this next example, list, also here is also as item 1, list 1 should be printed. List 1 in the sense, second item in the list. Second item, what is the second item in the list? Its value is 0, then its value is 1. The second item will be 34, then 34 will be the answer. In string also you can follow all these rules, but here not for this whole word, whole character will be the value 0. It will start from, for h value will be 0, then e value will be 1, then 2, 3, 4 going on. Then here is also as the value string 1 should be printed. So what is the first place? E will be printed. The second character in the string will be printed now. And the positive and negative indices. Positive and negative indices. First you can see the positive indices. It counts from the left starting with 0. It will count from the left like it will start from 0, 1, 2, 3, 4 normally. So T1 will be ABC. Next negative indexes count from right starting with 0, 1. It will start from right side like here -1, -2 and -3. Here they asked for -3 value. -3 value will be 4.56. Then next, this is positive and negative indices. Here slicing, return the copy of subset. Return a copy of the container with a subset of the original members. Start copying at the first index and stop copying before second. They give the asked output is t is 1 is to 4. 1 is to 4 means it will start from first and ends before 4. This is the starting value, this is the ending value. Then the first starting value will be from 1. So what's 0, 1? It will start from A, B, C, then 2 and 3. It should be end before 4. Before 4. What's before 4? This is the fourth value, then before 4 means 2 comma 3. So the one value is ABC, 2's value is 4.56, then the 3's value is 2 comma 3. This is slicing. Some more examples in slicing, but in different ways. Now they asked for t is to 2 value. Here this means the output should end before 2, index value 2, the output should be ended. What is in the second position? 4.56 is in the index value of 2, so the remaining value before this will be printed. Remaining values are 23 and ABC are printed. Likewise, now we have seen before the first index to make a copy starting from beginning of the container. Now we will see the second index to make copy starting at first index and going to end. Here the given indexes are this. Now it should start from 2 and it can be going on till the end of the list or tuple. Or the output will be starting from 2. What is in the second index? 1, 0, 1 and 2. It will start from 4.56 and it will go till the end of this. What is the end will be? This DEF will be this the end. So 4.56, 2 comma 3 and DEF. This is the returning copy of a subset. Now copying the whole sequence. This mentioned square bracket within square bracket, colon within square bracket makes a copy of an entire sequence, which means, as we seen previously, the t value is this. Then if we give the input as square bracket within colon within square bracket, means it will copy the whole and print as it is. It will print as 23 ABC 4.56 as it is. Next, we'll use in operator in this. We can see the boolean test whether a value is inside a container or not. Now we can take t as 1, 2, 3 or 4. We will check 3 in t. It will check as 3 is in t or not. We can say 3. 3 is not present in the t container, so it will return as false. Now we'll check 4. 4 is present or not. 4 is there, so the value will be written as true. This for substring. A value is equal to a, b, c, d, e. Same operation done here in string we are going to do here. C is in a or not. C is obviously present in A, so the value will be true. C and D is present, so the value will be true. Note a point that the in keyword is also used in the syntax for loops. And plus operator produces a new tuple, list or string whose value is concatenation of its argument. Now first we can take these two tuples 1, 2, 3, 4, 5, 6. By adding these two tuples we can get so single tuple as same one 1, 2, 3, 4, 5, 6. Next we can take list the same thing as we same operation we done before. 1, 2, 3. This is one list, then 4, 5, 6 one list. By adding these two we'll get this answer. Then by now adding this string hello world, if we add this if we add this we'll get only hello world, but we know Python will also take the white spaces. Now we have given the white space here, it will also consider this white spaces, then it will give a output as hello world. Multiplication operator, which means it will multiply the given tuple list or string. It will repeat the original content. Now see, first tuple, we'll take a tuple as 1, 2, 3 and we'll multiply it to 3. It will produce continuously repeatedly once again 1, 2, 3. Then after second time 1, 2, 3, then the third time as 1, 2, 3. Likewise it will perform with list. By multiplying the 3 we'll get 1, 2, 3 once, then 1, 2, 3 twice, then 1, 2, 3 thrice. Now we are printing this string into 3 times. This hello will be printed as 3 times again and again. It will repeat hello, 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 hello. Likewise, this is the use of this operator. Next, we'll go with mutability, tuples versus list. Now we already know that lists are mutable. We can change list in places. See here, li is equal to the set of containers inside this. The li place 1 is equal to 45. Now if we printed this li, this place will be replaced as 45. Now see, so this is why this list is mutable. Lists are mutable. We can change the list in places. After we change it, the li still points the same memory reference when we are done before. First it was 23. The li still points this memory. After we done some changes, the li will also show this same memory again. Tuples are immutable. Here t is equal to some values. Then we can if we perform this L1 by we perform operation by replacing L1 as 45. Since lists are mutable, we done this operation easily, but tuples are immutable, so it cannot be done. It will show error. We cannot replace t2 as 3.14. We cannot change the tuple. We can make a fresh. To avoid this, you should make a fresh tuple and assign its reference to previously used name. This immutability of tuple means they are faster than list. Also, tuples are immutable, but they are really faster than list. Next is operations on list only. In list, we can perform many operations like first is list.append a. First, append means we should add some value in the previous list. Now we are appending a in li. The li's original value is 111,345. After appending a, the a will be printed at the last of this list. Then now we are inserting 2 and I in list. After inserting, we'll get 2 comma I. This 2 is not the value we should insert. This is the position where we should insert this value I. In the second index value, we are inserting the value I. After inserting, it will change as I. We will insert the value I in second position. Then the other positions will move to next positions. Next is the extend method versus plus. Like, plus creates a fresh list with a new memory reference. Then extend operator on list li is li in place. Li dot extend. We can extend this thing by adding all these things, the 9, 8, 7 in this previous list. Our previous list is this. After extending, it will change it to the added values like 9, 7 in this list. Actually, we most of us confused with the extend and append. Of extend takes list as an argument, append takes a singleton as an argument. This is the difference between the li dot extend and li dot append. Next is operations on list only. In list, we can do operations like index, count, remove. This operation can be performed in list. First, we can see index. It will return index of first occurrence. Now we can ask the value. We can ask the index value of b. B is in the index value of 1, so the output will be 1. The next li dot count b, number of occurrence, it will count till b. If li dot count b means within which position, in which place it is, first and second place, so the value will be returned as 2. And li dot remove b, uh, we can remove this operation which is first in the list. Remove first occurrence, it will remove the first occurrence. There is 2b in our list. The first occurrence is in the first position of our list, so this b will be removed and the output will print as a, c and b. Next one is reverse. Reverse will reverse all our list by the normal is 5 to 6. Then after reversing this, we'll get 8, 6, 2 and 5, 8, 6, 2, 5. Then sorting. Sorting is sort the list in places. It will sort into in ascending order or descending order. Here it is sorted as ascending order, lower level to higher, 2, 5, 6 and 8. The total summary is can be modified and they have lots of handy operations and methods. Tuples are immutable and have fewer features. To convert between tuples and list uses the list and tuple functions. We can convert this list into by giving this list of tu, then tuple to list as tu is equal to tuple of li. Yes, thank you. I hope you all understand and you all had a useful session today. Thank you.